So it's my pleasure to introduce Professor Wim Deferme. He will talk to us about ACT 3D, Assembly and Connection Technology for 3D Plastic Carriers. Please.
Okay, thank you for the introduction. So indeed, I'm Wim Deferme. I'm working at the Institute for Materials Research, IMO-IMOMEC, in Belgium, in Hasselt, which is an affiliated lab between the University of Hasselt and IMEC. We work on innovative materials from, let's say, the synthesis at the chemistry side up to the devices and upscaling. I'm mainly working on functional coatings and printed electronics. And today I would like to talk about assembly and connection technology for 3D plastic carriers, ACT 3D, which was a project that we did together with Siris in Belgium, Fraunhofer IEM, and Hans Schickert in Germany, in the framework of a collective research network, where we had a lot of companies from the different regions, so the Flemish region in Belgium, the Walloon region in Belgium, and also from Germany, that followed the research that we did on this assembly and connection technology. And that was related to, let's say, this figure here, where we focused on what are the possibilities of metallization, so printed circuits onto different substrates. How can we then attach dies and SMD components on these, and how can we form them to have, let's say, 3D printed integrated hybrid electronic components, like you see, for example, here. That was the aim of the project, also to show to the companies what are the different strategies, the different technologies that you could do. And today I would like to talk about the screen printing and the 3D forming, so the thermoforming of these screen printed substrates or screen printed circuits to attach electronic components on these. So let's first start with the polymer, the substrate selection. We selected a few of those. You can see here the different substrates that we started with. And if you think about screen printing and then following thermoforming or vacuum forming, then of course you have to take into account a lot of properties that can have influence on the process itself. So we dived into that. We looked at, for example, the storage modulus, which in principle, looking also at the thermal expansion coefficient, could already indicate which polymers, which substrates could be useful to be used in the following project. So this, for example, is an substrate that we heated, not thermoformed yet, but heated, where you see already that it's not stable up to a certain temperature. So then taking that substrate, screen printing on it is possible, but then doing the thermoforming will bring you some issues. So this is what you see before you do the thermoforming. You go to, let's say, a temperature of 120 degrees centigrade, and you see already that it's not stable anymore. So the storage modulus is a very important one there. And of course, you have craquelation of your printed tracks, so that is something that we need to keep into account. So that is a first thing, and based on that, we made already a selection of a few substrates, PMMA, PC, PETG, and ABS, that we were investigating further. And we first looked at the screen printing process itself. So we have this Bacchini semi-automatic screen printing installation, which we used to deposit our printed circuits. You see some printing parameters. Important to note, here are the drying conditions. Typically for the inks we used, you go to 120 degrees centigrade. We stopped at 60 degrees and did that for 20 minutes. I will show you later why exactly we did that. And like I said, we worked on these polymers, these substrates, using a very broad range of inks. I showed 4, but we even have had 7 or 8 inks that we tested, and I will explain later. Here, for example, an example of a certain ink on polypropylene, where you see that the influence of the different parameters of your screen printer are very important. Looking at squeegee pressure, you see that your printed line width changes depending on your squeegee pressure, where you measure at, let's say, the edge or the outer edge and the core of the sample. So based on that, also the print speed is important, changing your line width, and also, of course, your snap-off distance between your substrate and your screen is important. So we optimized that